Hello students. Today I am going to explain briefly on unit number 16, grade 10, changes in matter. So what we have done in the previous physical class will be explained briefly here. So what are the physical and chemical changes found in day-to-day activities? So I mentioned in the class that the physical changes, the matter changes its form. That means state of matter changes. So no any chemical changes occur here. You don't find a new product here. Actually, in physical changes, the state of matter changes from solid to liquid, liquid to gas, or again by condensation, the gas become liquid, or upon freezing, the liquids become solid. So, in physical changes, you see that only the change of matter changes. But in chemical changes, there is a chemical reaction taken place. So, new products are formed. So, burning, for example, rotting of banana, any fireworks, rusting of irons, we say they are chemical changes. Chopping, melting, freezing, slicing, these are said as physical changes. So I said physical changes means change of physical state. Solid, liquid, gases. So they will change their form without giving new substances. So crushing stone is a physical change. Melting, vaporization, condensation are physical changes. But in case of chemical changes, so new products are formed. When you burn something, you will get ashes, oxides. So evolution of heat can be seen when a chemical change occurs. Formation of gases or the bubbles formations, change in color and precipitations are due to chemical changes. In chemical changes, remember, always you get a new product. So burning, heating, rusting are some examples for chemical changes. So what is a chemical reaction? So this is a process of formation of new products. You get new products here. New products. By making new bonds. Under bonds we learn there are two types of bonds, covalent bonds or ionic bonds. So they will make a new bond, new product. So they make bonds by exchanging electrons. Either by donating or gaining or sharing electrons. So in a chemical reaction, the substances that are taken part are called reactants. Substances that are newly produced are called products. So we use an arrow to show the conversion of reactant to products. So always remember in chemical reactions, we indicate with an arrow. Reactants to products. What are the types of chemical reactions? In this chapter, we will learn there are 4 types of chemical reactions. Chemical combination reaction, chemical decomposition reaction, single displacement reactions, and finally, double displacement reaction or double decomposition reactions. So these are the 4 types of chemical reactions. So we will explain further with examples on these types of reactions. Let's see what is a chemical combination reactions. So in combination reactions, what you get is a formation of a new compound. One compound is formed. One compound is formed. You see, for example, A and B produce one product. Only single compound. So this is how you identify the combination reaction. So for example, magnesium and oxygen, they react together and they give one product here, that is magnesium oxide. Nitrogen, hydrogen, they react together, they give only a one compound. We say it's a combination reaction. එතකොට combination reaction එකේ මතක තියාගන්න එක compound එකක්, එක molecule එකක් තමයි හැදෙන්නේ. Let's move on to the balance equations. So now I am asking a question here. Write the balance equation when magnesium, aluminium, copper, calcium and zinc are heated in air. We'll see step by step. every time when an element is heated, remember, every time when an element is heated in air or combustion or reacted in air, that means they are reacting with oxygen gas, O2 gas. When any of the elements, whether metal or non-metal, when you heated in air, when they are reacted in air, when they are combusted, දහනය කරු, රත් කරු. So they actually reacting with oxygen gas, O2. So the gas form of oxygen is not O atom, it's O2 molecule. So when they reacted with oxygen, they make oxides. They make its oxides. For example, magnesium, when you heated in air, means reacting with oxygen, and they give magnesium oxide. Carbon, when it is reacted in oxygen, it gives carbon dioxide. Sulfur, when they are reacted in air, heated in air, they give sulfur dioxide. Aluminium, when they are heated in air, it gives aluminium oxide. So remember, anything heated in air means reacting with oxygen gas, and they give the oxide, magnesium oxide. Now we are trying to write a balanced chemical reaction. So we know that the magnesium oxide is a compound which was formed by chemical formula method, that we have learned this chemical formula, how to make a chemical formula. So magnesium oxide, you can't just write as MgO. So you have to look at their valencies. So magnesium, 282, the valence is 2, oxygen valence is 2. Now since they are same, you cut off them. The final formula of magnesium oxide is MgO. So whenever they ask you to write a chemical equations, balance equation, if you find any compounds, so make the compound by this way, which we have learned under writing chemical formula. So now magnesium plus O2, you get the product as MgO. These are the reactants. So when magnesium is heated in air, means reacting with oxygen. So that is MgO, the product. So MgO you can't write just as your wish. You have to go back and see this formula, chemical formula. How do you write the chemical formula? Now what is balancing equation? This is also known as inspection method. That means the number of elements in reactants should be equal to the number of elements in products. So there is no creation or destruction of atoms or elements. So whatever the elements found in the reactants should be equal to the products. So here in this case, you have one magnesium and two oxygens. O2 means it's O and O, two oxygens. So altogether you have three elements, three atoms here. When it comes to magnesium and oxygen, only two elements are formed. So is it balanced or unbalanced? It is unbalanced. So how do you balance them? So remember, the next step is add or adjust the coefficient values. Coefficients, that means you can put a value here. But remember, don't put them in front. Don't put them as subscripts like this, but put them in front of the molecule or the element. හැම වෙලෙම ඉස්සරහින් තමයි දාන්න. අපි දාන value එක. This is a already formed one. Magnesium oxide is, we have formed it. Again, you can't put two like this, then the whole scenario will be changed. So whenever you want to balance the equation, you can add the values means the coefficients, only in front of the compound or the front of the elements, not in between or subscripts. Next. So when you get something like odd number, so for example here you get two oxygens and one oxygen in the product. So multiply the whole or multiply by 2 to make all even. So multiplication means you add in front of the molecule as 2. So these two belongs to both magnesium and oxygen. So hydrogen, here you have 2, that is even number, no problem. In here you have 3. එතකොට මෙහෙම odd number එකක් තියෙනකොට ඒකට ඉස්සරහින් දෙකක් දාගන්න. Now this become 3 into 2 6. So in case of aluminium with oxygen, you get Al O2. O2 means it's even number. Here you have O3. This is how you form by exchanging valencies, and you have written here the chemical formula or formula of aluminium oxide. So 3. This is even. This is odd number. So multiply by 2 and 2 in front of it. So you get 3 into 2, 6. What is the next step is? Yeah, remember always the coefficient value in front of a compound belongs to all elements in the compound. For example, in this case, if you put in front of aluminium oxide 2, this 2 belongs to aluminium and oxygen as well. So there are 4 aluminiums. So 2 into 2, there are 6 oxygen atoms are found. 3 into 2, 6 aluminium atoms are found. Now you have to check the balance equation and finalize the balance equation. Now we see that here you have a 2 in front of magnesium oxide, since you have to balance the oxygen here. Now check for the magnesium number. Here 2 magnesium and 2 oxygen. Oxygen number is okay. In front of magnesium we add another 2 here as the coefficient. Now this is a balance equation. Now check again the reactants individually. There are 2 magnesium atoms and 2 oxygen atoms. 2 oxygen atoms here. And these 2 belongs to both magnesium and oxygens. Again you get 2 magnesium and 2 oxygen. So the number of elements found in the reactants and products are same. So now we say this is the balance equation. So this is the final balance equation when the magnesium is heated in air. So this is how you write the balance equations. So check again nitrogen and hydrogen. You get the product ammonia NH3. So since 2 and 3, 3 is a odd number. So I put 2 in front of this NH3. We can't put anything in between or the back. Now check the balance. Now you have 6 hydrogen, 2 nitrogen. Now so nitrogen 2 is okay here in the reactants, but hydrogen are 2, only 2 hydrogen here. Now we add 3 in front of hydrogen. So it becomes 6. So now you can check the final equation. So there are 2 nitrogen in reactants. These are the reactants. ඊතලයට මේ පැත්තයි ඊතලයට අර පැත්තයි ගන්න. ඊතලයට මේ පැත්ත තියෙන ඔක්කොම එකතු කරන්න. Whatever the either sides of the elements, right? And the right side of the arrow and the left side of the arrows. So all elements found in the left side should be equal to the right side. So here 6 hydrogen, 2 nitrogens. These 2 belongs to both 2 nitrogen and 6 hydrogen. So this is the balance equation. Similarly, you can write it for aluminium when it is heated in oxygen. So now we balance it. There are 4 aluminium, so put 4 in front of aluminium. So there are 6 oxygen, 3 into 2, 6. So 2 was here, so we put 3 here. So now this is the balance equation for aluminium is heated in air. So these are the equations. Please try out when you do this calculation. Now this is the question. Try out with zinc, copper. You know, I have told you the valency of zinc, copper and iron to take it as 2. ඒකේ valency දෙක කියලා ගන්න කිව්වා. Copper, zinc, iron. වල valency දෙක කියලා අරගෙන ගණන් කරන්න. Right? So you can check your answers. Next we move on to the chemical decomposition reaction. So these all what we have learned here, these all are combination reactions. Why you have found only one compound here? Only one compound is formed. What is chemical decomposition reaction? Decomposition of a compound. One compound is decomposed. That means one compound is broken down into several simpler compounds. So A is a single compound, is broken down. So this type of chemical reactions we say chemical decomposition. For example, this is a very important one, potassium permanganate. When it is decomposed, you get K2MnO4, say potassium manganate, and another product called manganese dioxide and oxygen. So the single compound is decomposed or broken down into several simpler compounds. So this type of a reaction is called chemical decomposition reaction. තනි compound එකක් කෑලි කෑලි වලට කැඩිලා ගියොත් අපි කියනවා decomposition කියලා. So when you look at this type of reaction, you should be able to identify the type of the reaction. Another very most important reaction is calcium carbonate, limestone. When it is combusted, or when it is heated, when it is decomposed, so they give calcium oxide and carbon dioxide. So one compound is broken down. Hydrogen peroxide, H2O2 means, remember, hydrogen peroxide is decomposed to water and oxygen. So I explained what is hydrogen peroxide in your class. That is a chemical used as disinfectant to kill the bacteria. Actually, as when you have wounds, the doctor uses these hydrogen peroxides in a dark bottle. So which is when it is decomposed, it gives H2O and O2. So this is another important reaction. Hydrogen peroxide. This is also to make oxygen gas. මේ oxygen gas එක හදන එකක් තමයි මේක in the lab. So we use potassium permanganate decomposition reaction to produce oxygen gas in the lab. Oxygen gas එක හදන්න මේක පාවිච්චි කරනවා. එන්න පොඩ්ඩක් මතක තියාගන්න. Right? This reaction is. Another way of making oxygen gas is decomposition of hydrogen peroxide. So this is a very important calcium carbonate decomposition is very important to make. This is called calcium oxide, which is also known as quicklime. And this quicklime or the calcium oxide is used in ion extraction technology. So this reaction is one of the chain reactions of one of the chemical reactions of where you find in ion extraction. So this is also another important chemical reaction. So please remember this equation. Let's move on to single displacement reaction. In this case, a single element, an element displaces another element in a compound. For example, BC is a compound, B is an element, A is going to displace the B and it's going to combine with AC, C with C, and they makes a new product, AC. So B is displaced. So this type of chemical reactions we say single displacement reaction. So only one element can displace another element in a compound. එක compound එකක තියෙන element එකක් single element කෙනෙක් ඇවිල්ලා මෙන්න මේ compound එකේ තියෙන element එකක් displace කරනවා. ඉවත් කරලා දානවා. They remove one and they make a new product, AC for example. You cannot displace unless you are a high reactive element. Without, if you are a high reactive element, then you can displace. With low reactive elements cannot displace the high reactive elements. A එක powerful වෙන්න ඕනේ. Reactivity එක වැඩි වෙන්න ඕනේ. B එක low reactive වෙන්න ඕනේ. එතකොට තමයි A ට පුළුවන් B ව displace කරන්න. In case of if say we say A is low reactive, B is high reactive, then this chemical reaction will not be taken place. Our single element should be high reactive. If it is low reactive, this reaction will not be taken place. So remember that point. Only a high reactive element can displace a low reactive element in a compound. This is called single displacement reaction. So for example, zinc is going to displace copper in copper sulfate compound. So zinc is going to make a bond with sulfate. So they makes a new product, zinc sulfate. So magnesium here is going to displace hydrogen. When hydrogen is displaced, it is a gas, so it will go as a diatomic molecule. So any gases except helium, neon, argon, so they generally found in diatomic form, H2. Oxygen gas is O2, nitrogen gas is N2, fluorine gas is F2, chlorine gas is Cl2, Cl2. So this is how this single displacement reaction is taken place. When you add sodium to water, so hydrogen is displaced. Sodium is going to act with OH and they make sodium hydroxide. You should be able to recognize when you see a chemical reaction whether it's in which type of reactions. So how do you select the reactivity of the elements in case of single displacement reactions? So there is a reactivity series of metals that are arranged in their reactivity in descending order. How they react with air, water, and diluted acids. So based on this reactivity, there is a reactivity series developed, right? So you should remember this series I have explained in your class. You should remember the descending order of this reactivity series. Potassium, sodium, calcium are highly reactive elements. They react fast with air, water, and dilute acids. So that is why they are stored in kerosene or paraffin oil because of their high reactivity. So magnesium, aluminium, zinc, iron, Sn means tin, Pb means lead. So they are being moderately active elements. So hydrogen is used here for comparison of reactivity. So it's not a metal, just used to compare this. Copper, mercury, silver, platinum, gold. Au means gold. So you should remember these elements with their symbols. So this is the reactivity series based on how they react with air, water, and dilute acids. Those who are below hydrogen, these metals are with low reactivity because they do not react with air, water, and dilute acids readily. මෙන්න මේ series එක මතක තියාගන්න ඕනේ. So I explained in your class how to memorize this. So you can memorize this. I have given a small idea. Please stop calling me a zebra. Instead, try learn how copper saves gold. Please means potassium, sodium. Stop calling means calcium. Me means magnesium. A means aluminium, zinc, zebra, iron. Instead, try learning how hydrogen, so copper, saves means silver, gold, right? So in between these you get mercury and platinum. මෙන්න මේ series එක මතක තියාගන්න ඕනේ. Without knowing this memorization, you cannot go head further in chemistry. So I explained in chemistry you should know the periodic table, the 20 elements and the polyatomic ions along with their valencies and their formula, and the last one is reactivity series. So these three things should be memorized. Otherwise, it will be difficult for you to answer your question papers. So reactivity of metals. So I said sodium is in top. So they react with air very fast. So that is why they keep in paraffin oil. So magnesium also, when it is heated, it reacts very fast and it gives a white powder of magnesium oxide, you know, the bright white flame with magnesium. The middle ones, that zinc, copper, iron, when you heat them, they become dull. But silver, platinum, gold, they will not form oxides. Nothing will happen to them. So that is why the gold is very expensive, because over time, so they don't make oxides. So the luster do not disappear. They do not react with water. They do not react with dilute acids. So that is why the gold is very expensive, even the platinum, silver. Reaction of metals with water are concerned. So you know the sodium is readily react very fast. They react with cold water and they give sodium hydroxide and hydrogen gas. So this is the balance equation. You know how to write the balance equation, how to balance them. And they form a basic solution which gives red litmus to blue. Or phenolphthalein is another chemical used to identify the basic solution which turns to pink. And magnesium do not react in cold water. We know this. We have learned this under structure of matters. They react with hot water. When they react with hot water, they give magnesium hydroxide along with liberation of hydrogen gas. When magnesium is reacted in steam, they give magnesium oxide. So magnesium do not react in cold water but react in hot water and steam. So iron, zinc, those who are in the middle, they do not react even with hot water. They react with steam. But remember, silver, platinum, gold, they do not react with hot water, cold water, or steam water. Steam. Because their reactivity is very less. As far as the reactivity with acids are concerned, the moderate ones, the middle ones, the moderately reactive elements, they react with acids and they give hydrogen gas rapidly, fastly. So you know that there are acids found in your lab: hydrochloric acid, nitric acid, and sulfuric acid. H2SO4, nitric is HNO3, hydrochloric is HCl. So how do you write this chemical reaction? You know, this is a single displacement reaction. Magnesium is going to react with chlorine here. Hydrogen is going to displace. So you can't just write MgCl. So check the valency of magnesium and chlorine and then exchange them and then make their formula, magnesium chloride. Similarly, aluminium chloride. Zinc, I said the valence is 2. Zinc chloride, iron chloride. Then you have to check the balancing with values. ඊට පස්සේ balance කරලා බලන්න values ටික. But sodium, potassium, calcium, we don't try to make them react with acids because they react very violently with dilute acids. So they might give explosions or ignite with fire. So it's dangerous to make the reactions of metals like highly reactive metals like sodium, potassium with dilute acids in your lab. So highly reactive metals, they react violently with dilute acids. So we generally use zinc and magnesium to produce hydrogen gas in the lab because it's safe, because it's not violent react. They moderate react and give hydrogen gas. But you know, the mercury, silver, platinum, gold, they do not react with dilute acids. So because their reactivity is very less. Those who below hydrogen, remember that, below hydrogen, they do not react with acids. As I said, the solutions like copper sulfate and zinc. Now zinc is going to react with copper sulfate where the copper is going to displace. And zinc is going to make zinc sulfate. This is, as I said, an example for single displacement reaction. But in order to displace copper, you need a high reactive element. As far as the reactivity series is concerned, zinc is high reactive when compared with copper because zinc is above the copper. So zinc is highly reactive, so that zinc can displace copper in this reaction. එතකොට මේකේ copper එකට වඩා zinc ඒ reactivity එක වැඩි හින්දා තමයි zinc ට පුළුවන් වෙන්නේ මෙන්න මේ copperව displace කරන්න. So you know the copper sulfate is a blue solution. When the reaction is taken place, you know the something that the color will change here. This becomes colorless solution. The copper is a reddish brown deposit. So you will observe reddish brown deposit when this reaction is taken place. So this is another example for single displacement reaction. But remember, copper cannot displace zinc here. Copper is a single element. Can it displace this zinc? No. Because copper is low reactive than zinc. Only high reactive element than this compound, the element found in the compound, can displace the element in the compound. So only with metal with more reactive can displace. So that this reaction will not take place. So these are the users, some of the users of activity series. So you know that the sodium, potassium, calcium are highly reactive. So we will take precautions to store these metals. And sometimes we use this reactivity series to prevent corrosion of metals. Sometimes to prevent iron, we use rusting of iron. We use the elements above, more reactive elements than iron. Iron is sometimes combined with zinc here because zinc is more reactive than iron. So instead of oxidation of iron, zinc will get oxidized. So the iron is protected. This is called cathode protection. We will learn in detail in grade 11 under electrochemistry. And also to make to extract metals, we use this reactivity series under electrolysis, right? And also this reactivity series is used to make electrochemical cells. So we will learn in detail again this in grade 11 under the electrochemicals. And also certain moderately active metals are extracted by a reducing or reduction method like iron, tin, zinc, lead. So you can identify how these metals can be extracted using this reactivity series. Those who are in the bottom, they are simply we can separate them or extract them using physical methods by sifting, by sieving, by having a high pressure gun, right? Easily වෙන් කරගන්න පුළුවන්. So this is very important. So remember in MCQs they will ask the method of extraction of certain elements or the metals. So those who are up, potassium, sodium, calcium, magnesium, including aluminium, so they are extracted as the method called electrolysis. Those who are in the middle, zinc, iron, tin, lead, even including the copper, they will be separated as reduction method. So you know, the sodium is, you don't find sodium native metal element in the nature. Sodium is actually found in sodium chloride in sea. So we, in your lab, the sodium metal is not, it's a natural one. So that sodium is extracted from seawater using this method, electrolysis. Grade 11 wala api make explain karna what is electrolysis, right? And the middle ones are method called reduction. Those who are in the below ones, general physical methods, right? Let's move on to the last type of reaction, that is double displacement reaction. So under double displacement reaction, the two compounds, you see AB is a compound, C is a compound, they exchange either elements or the radicals or sulfate, nitrate, hydroxide element. What they do is they exchange each other and they make new compounds. Two new compounds are formed, two or more new compounds are formed by exchanging the elements. So two compounds exchanges and making two compounds. Sometimes you get three compounds. For example, sodium hydroxide and HCl are two compounds. They give two compounds, sodium chloride and H2O. Sodium goes with chlorine, H goes with OH. They make water molecule. Sodium sulfuric acid, H2SO4. Sodium go with sulfate, H go with OH. These are double displacement reaction. Calcium go with Cl, H go with carbonate. So they will be broken down into again water and carbon dioxide. So this is calcium carbonate with HCl is a double displacement reaction where this is used to produce carbon dioxide gas. Any carbonates, any bicarbonates, when they react with acids, you can get carbon dioxide gas. Try to answer these questions quickly. Write the activity series of metal in descending order. You know that we have discussed. So this is the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. State metals react fast with air and write their balance equation. Try to write. Yes, those who are on top of the reactivity series, potassium, sodium, they react very fast with air. This is their chemical reactions. Please try to write the chemical reactions, right? Sodium and oxygen gas. Sodium and oxygen, sodium oxide is formed by the valency exchanges. Sodium valency 1, oxygen valency 2, 2 goes to here. Sodium 1 here, Na2O. Now you balance it. And this is the final formula, right? Final equation, balance equation. State a metal reacts fast with cold water. You know that is sodium and potassium, right? With water. Sodium with water. So this is the balance equation. Now you should be able to write them. Sodium is reacted with water. It gives sodium hydroxide and hydrogen gas as the products. Now you can balance the equations. So cold water, the sodium react very fast and they liberate or they produce hydrogen gas. And they make a basic solutions which turns red litmus to blue or it becomes pink with phenolphthalein. Write the balance equation when magnesium reacted with hot water and steam. So the thing, this is a very important another reaction. With hot water they give magnesium hydroxide and hydrogen gas, the balance equation. You write and practice it. Reaction of magnesium with steam, you get magnesium oxide. Please again remember with steam magnesium oxide. State metals that do not react with dilute acids. I told those who below hydrogen, they do not react with dilute acids. So copper, mercury, platinum, silver, gold. State metals violently react with dilute acids. Those who are stop, sodium, potassium, calcium. Those who moderately react with dilute acids, generally we use zinc, magnesium, aluminium. So they moderately react with dilute acids. Balance equation with magnesium and HCl and sulfuric. Please try to do it, try to write it and check your answer is correct. So magnesium with HCl, they form the magnesium chloride. So this is by valency exchange and hydrogen gas. So 2 chlorine, 2 hydrogen, we put 2 in front of HCl here. Magnesium with sulfuric acid. So magnesium go with sulfate. Sulfate valency 2, magnesium 2, 2, 2 cut off. You get magnesium sulfate, hydrogen displaced as hydrogen gas. So check whether they are balanced. Yes, 1 sulfate here, 1 sulfate. 2 hydrogen here, 2 hydrogen. 1 magnesium, 1 magnesium. It's a balance equation. Similarly, you can try with balance equation with zinc and hydrochloric acid and sulfuric. Zinc, I told the valence is 2. Please check the answer here. State 2 metals that react with copper sulfate solution. So 2 metals that react with copper sulfate. So which elements that can displace copper? Those who above copper can displace. So you can use zinc, magnesium are generally used in your lab. So in addition, you have aluminium, iron, those copper metals react කරනවා copper sulfate because the copper is low reactive element. So those who are above can displace this copper. So you know that the copper sulfate is a blue color solution. So this becomes colorless and the copper is deposited in this solution. Copper is a reddish brown deposit. Two observations. So what are the observations you see here when this reaction is taken place? That zinc or the magnesium with copper sulfate, the color disappears, blue color diminishes, and formation of a brown powder because of the deposit displacement of copper. State two metals that do not react with copper sulfate, those who below copper do not react with copper sulfate, කවුද කට්ටිය? Anything like silver, platinum, gold. The next one is state 3 metals that protect iron. And iron rusting again protect කරන්න නම් above elements ගන්න ඕනේ. Because they will oxidize more than iron. So the oxidation of iron is protected. So rusting means iron become oxidized. Iron react with oxygen and water. So instead of iron, high reactive elements than iron will react and they protect iron. So those who above iron, like magnesium, zinc, aluminium, protect iron from rusting. Metals do not protect iron, those who below iron, like tin, lead, copper, silver, megolo, they can't protect iron from rusting because they are not reactive. Instead of them, iron will become oxidized and they become rusted. So method of extraction of these metal, as I said, sodium, potassium, calcium, by electrolysis. Iron, lead, zinc, copper by reduction, silver, and it should be gold here, right? Gold, we say, are physical methods. So look at this, I told you the method of extraction. So these are the method of extractions: electrolysis, reduction, and physical methods. So now you can try with writing balance equation for these things. So please try to do it. Make a ලියලා බලලා check කරන්න your answers. මෙන්න මේ මම answers දීලා තියෙනවා. So you can check the answers, right? You try to do it. Next, we are going to talk about extraction of iron. Another interesting subtopic in this particular unit. So this is what we are going to do is we are going to extract iron from the natural source of iron. The natural source of iron is, we say, this is actually the iron is taken from iron ores. The chemical formula of this natural source is called hematite, that is Fe2O3. So that is Fe2O3. This is where you get the iron Fe2O3 in naturally. So our main task is to remove this oxygen from this compound. So remember the main component where the natural iron exists in the form of hematite. Generally we say Hem means iron. So it's combined with oxides. So now our main task is to reduce this oxygen and to extract this iron from this hematite. So අපි යපස් කියලා කියන natural source එක මේ iron එක තියෙන. This is where you get the natural source of iron. So this iron extraction is taken place in a special furnace called blast furnace. This is around 60 meter high. So inside temperature is around 1000 to 1900. In order to extract iron, there are three main raw materials are used: iron ore or hematite, and limestone. So this is limestone here, and the coke. Coke means aranguru wage, right? Not the Coca-Cola. This is carbon containing sauce. අපි barbecue දානකොට අපි carbon අපි use කරනවා charcoal, so it will increase the temperature. So similar thing is happening here. In order to increase the temperature inside the furnace, we use coke. So remember, our main target is to remove oxygen and take this iron alone. So as far as this blast furnace is concerned, the raw materials are inserted from the top. මේ උඩින් තමයි දාන්නේ. Hematite, limestone and coke are inserted or added from the top. Actually, this blast furnace is made out of bricks, right? And then when you add these ingredients or the raw materials, so inside the blast furnace, right? So we send hot air. We send hot air from here with the temperature, we say, for example, 650 Celsius, right? So initial temperature is around 650 Celsius. So what happens? A series of chemical reactions are taken place inside this blast furnace. And finally, the iron is extracted and it will be deposited in the bottom of this blast furnace as liquid iron. Liquid iron විදිහට මේ iron එක පල්ලෙහාන් float වෙනවා, deposit වෙනවා as in the form of liquid. So there is an iron out here. මෙතන තියෙනවා out එකක්. අපි එළියට ගන්නවා iron එක. Molten iron. Molten iron means the fused iron or the iron in the state of liquid. So this is called the molten iron out. On top of this iron layer, liquid iron, you get slag, impurities. So that is removed, right, from slag out. This is called the slag out. ඔය slag කියන්නේ ඔය අපද්‍රව්‍ය තිබුණොත් waste impurities තිබුණොත් ඒවා මේකේ හැදිලා ඒවා remove කරනවා as slag out. So molten out in the bottom on top of molten iron, so you get slag out because the density of the slag is less than the iron. So here you get the temperature, as I said, approximately inside this blast furnace around 1750 Celsius in generally as average. 1750, 1800, maybe up to 1900. So this is the temperature where the iron become molten or become liquid. යකඩ liquid වෙන temperature එක 1750 එකයි, we have to give this temperature. So initial temperature, as I said, it was 650 by coke. So we are adding coke here. So coke will increase the temperature inside where it is required to melt iron. And it will increase about 1700, 1800, between 1000 and 1900. And the limestone is used here. As I said, the limestone is used as an ingredient or raw material. That is to make the impurities. That is to remove the impurities. Let's see what happens. The chemical reactions taken place inside this blast furnace. The hot air means oxygen. Remember that. The hot air means around 650 Celsius, we send oxygen gas. So when this oxygen is get in, this oxygen react with coke. Oxygen reacts with coke. And it makes carbon dioxide. So this is the first reaction that is taken place inside this blast furnace. At the same time, this coke will increase the temperature where it is enough to melt iron around 1000 to 1900. Again, 1750, 1800 වගේ මේක වැඩි කරලා දෙන්න. So this carbon dioxide further reacts with the coke, the next reaction, and it makes carbon monoxide. මේක හදනවා carbon monoxide. When you balance it, it becomes 2CO. Carbon mono means one oxide. Carbon monoxide. So this carbon monoxide is the reducing agent where it removes this oxygen from this hematite. So you get the pure iron here, only iron here. The main reaction that is taken place inside this blast furnace where the liquid iron is produced is this. Fe2O3 reacts with carbon monoxide and it gives iron, the molten iron or the liquid iron, and also it produces carbon dioxide. So this is very, very important reaction where it is taken place inside the blast furnace. This is the main reaction actually. So Fe2O3, 3CO, 2Fe, when you balance this equation, you get this final equation. Now the iron molten is there in the bottom of the furnace where this iron is, molten iron is removed from molten iron out. At the same time, we use calcium carbonate in this. So decomposition of this calcium carbonate is taken place inside the blast furnace. We said that the limestone, that is calcium carbonate, is one of the raw materials. So this will be decomposed to calcium oxide and carbon dioxide. This calcium oxide actually reacts with the impurities. So the main impurities that are found in this iron ore are silicon dioxide, that is SiO2, and aluminium oxide, or we say alumina, Al2O3. This calcium oxide reacts with silicon dioxide and it makes calcium silicate, CaSiO3, as well as it reacts with aluminium oxide, Al2O3, and it makes calcium aluminate. So both of these compounds we generally called as slag, where the impurity is found in the iron ore. So that are floating on top of the molten iron, which is removed from the slag out. So these are the series of reactions that are taken place inside this blast furnace. Right? Right? So you know that this technique was not newly introduced one, right? And this is from ancient time. This iron melting technology was used in Sri Lanka before Christ, around 3000 BC. Especially you have learned this in your history in the area of Samanalakanda and Sigiriya areas. These furnaces, these are the old furnaces where it is still found in Sri Lanka. Next, extraction of gold. So you know the gold is less reactive element. It does not make any oxide. So they can be separated by physical methods like sifting. So these are found in gold mines. So you just take the gold and you can remove the gold by sifting process or simple physical methods, right? Now, can you answer these questions quickly? What is the equipment used to extract iron? Yes, blast furnace. Can you draw a sketch and label the above equipment? Yes, can you label this A, B, C, D and E? A is, you know, that is molten iron out. B is slag out. E is hot air. D is where the raw materials are added. C is where these we say waste gases. You know, there are carbon dioxide and carbon monoxide that are the waste gases produced inside this blast furnace that will be released into the environment. So due to this carbon dioxide, you will get impact. It will impact on the environment, which causes global warming. So that is another point you should remember. So certain questions are given. You try to answer these questions, right? So answers will be shown here. Please go through this and try to answer the questions. May reaction series second. Remember, carbon with O2, CO2. Carbon with CO2, 2CO. This is the main reaction. Fe2O3 plus 3CO, and it makes 2Fe plus 3CO2. So that means 1 mole of hematite reacts with 3 moles of carbon monoxide to produce 2 moles of iron and 3 moles of carbon dioxide. And this is a decomposition reaction which is taken place inside the blast furnace, and this is where the slag is made. So the method of extraction of iron is reduction. So the reducing agent that was used is carbon monoxide. Aluminium and silicon are the impurities found in this blast furnace. Next, we will be moving on to certain calculations based on the moles concept and the balance equations. I'll explain only one part of this. You try to write the answers for the rest of the questions. I'll explain one. Look at this question. What is the number of moles of oxygen gas required to react with magnesium to obtain 6 moles of magnesium oxide? මේ වගේ ප්‍රශ්නයක් ආපුවා මොකද කරන්න ඕනේ? Number of moles of oxygen required to react with magnesium to obtain 6 moles of magnesium oxide. So first thing is you must write the balance equation. So magnesium is reacting with oxygen. You know, I have explained any metals or non-metals, when they react with oxygen, they give oxides. Oxygen means O2 gas. So let's write it. Balance equation. The balance equation and take the ratios. Now they are asking the question on magnesium, oxygen and MgO. How many number of moles of oxygen required to make 6 moles of MgO? Make a බැලුවම අපිට පේනවා 2 magnesium react with 1 oxygen. So here in front nothing is there. That means 1 mole of oxygen, 1 oxygen, and it gives 2 molecules or moles of magnesium oxide. In oxygen එකක් මෙතන එන්න ඕනේ ඇත්තටම එක කියන එක, right? But we don't write here, right? 1. So 1 mole of oxygen gives 2 moles of magnesium oxide.
So to give 6 moles of magnesium oxide, they are asking how many moles of oxygen is required. මේක දෙකක් හදන්න මෙයා එකක් ඕනේ නා. Magnesium oxide 6ක් හදන්න oxygen කොච්චරක් ඕනේද? So you know that is simple calculation. You get 3 moles of oxygen. So take the ratio. So the answer is 3 moles of oxygen. එකට දෙකයි. 1:2 ratio. To get 2 magnesium oxide, you need 1 oxygen. You need 1 mole of oxygen is required to get 2 moles of MgO. So to get 6 moles of MgO, you need to combust or heat with 3 moles of O2. What is the next part? What is the mass of oxygen required to react with magnesium to obtain 120 gram of magnesium oxide? The මේ වගේ ගානක් ආපුවම පුතා, first convert the grams into moles. So they say we will find out first how many moles are found in 120 grams of MgO. So before that you should calculate the molar mass of MgO. So the you will be able to calculate as 40. That means in 1 mole you get 40 grams. So based on this equation, number of moles equal mass over molar mass. So we have done this in our under the Avogadro concept and mole concept. So in 120 grams of magnesium oxide you have 3 moles. එහෙනම් 3 moles හදන්න නම් MgO 3 moles හැදිලා තියෙනවා 120 grams වලට. oxygen වල moles දාන කීයද? So 3 2, that means half. If it is 2, this is 1. That means 3 moles means you get oxygen as 1.5 moles based on the ratio. So in 1.5 moles of oxygen, how many grams or the mass of oxygen are found? That is also simple calculation. Mass එක හදනවා නම් කෙලිම number of moles multiplied by the molar mass. So the molar mass of oxygen gas is O2. That is 16 into 2, that is 32. So you get 48 grams of oxygen required to produce 120 grams of magnesium oxide. එහෙනම් ඉස්සෙල්ලාම magnesium oxide 120 ග්‍රෑම් හදනවා නම් ඒ 120 ග්‍රෑම් කියන මෝල් වලට හරවන්න 3 moles. එහෙනම් magnesium oxide 3 ratio බලන්න. 3 moles දෙනවා නම් oxygen mole කීයක් දෙනවද? එතකොට මෙයා දෙකට එකයිනේ. oxygen එකට දෙකයි. magnesium oxide දෙකට oxygen එකයි. එතකොට එකෙන් half. oxygen mole ගාන 1.5. mole ගාන mass එකට හරවන්න නම් molar mass එකෙන් multiply කරන්න. So molar mass of oxygen, now we need to find the mass of oxygen. So multiply it, you can get the mass of oxygen here. And similarly you can calculate what is the mass of magnesium oxide produced when 100 grams of magnesium is reacted. Make a workout karanna. So there are different other ways. So I have explained different ways to get this answer done. When make a check karaganna answers hadaganna. Again, another example, what is the number of moles calcium carbonate required to produce 12 moles of carbon dioxide? First thing is write the balance equation. When a balance equation එක ලියන්න. Ratio එක ගන්න 1 1 1. Ratio is 1 1 1. So to produce 12 so you're asking how 12 moles of carbon dioxide හදන්න moles කොච්චරක්? Number of moles ආන්නේ. Calcium carbonate required. So that is 12 because the ratio is 1 to 1. And then what is the mass of calcium oxide required when 300 grams of calcium carbonate is decomposed? එහෙනම් moles ගන්න බලමු calcium carbonate gram 300 තියෙන. You know calcium carbonate is 100, molar mass is 100. So 300 grams means mass over molar mass is 300 over 100 is 3 moles. So 1 to 1 ratio you get then 3 moles of calcium oxide as well. එකට එකනේ එහෙනම් මෙයා තුනක් decompose වුණොත් calcium oxide තුනක් හැදෙනවා. Mole 3 mole calcium oxide now convert to grams. And calcium oxide means 40 plus 16 56. That is molar mass multiplied by 3. So you get the mass of calcium oxide 168 grams. This is the easy way you can calculate this calculation, and I have shown other ways where different methods that you can get the same answer of 168 here, and another question is asked, so the answers are given here. Please try with yourself. Again another calculation and make a try karanna. The same method I have explained. Number of moles of hematite required to produce 2 moles of Fe. Write down the equation. 1 to 3 2 to 3 ratio. So to produce 2 moles of ions you need 1 mole of Fe2O3. So to produce 1 mole of iron, half. Then අපෙන් අහන්නේ ඒක නෙමෙයි. To make 2 moles of iron. 2 moles of iron, what is the moles of hematite? Fe2O3 required. That is 1 mole. 1 to 2 no ratio. And then they ask in 3,200 grams of hematite when it is reacted, how much of iron is made. So simply convert it into moles, check the ratio. So iron doubles 40 moles and multiply the molar mass of iron with number of moles, you get the number of grams. So we can do these calculations to practice. So there's another question here. Make a whole color, make gana hadanna, and you can get the answers, right? Next. We'll make a try kala balanna. The last part of this chapter is production of gases in the lab. මෙන්න මේක තමයි අන්තිම part එක මේ structure of matters වල. Production of three gases are discussed in your textbook: hydrogen gas, oxygen gas, and carbon dioxide gas. So you need to learn about their properties, physical properties and their chemical properties, how do you prepare them, and their uses. So මේක ගැන හොඳ idea එකක් ගන්න. ගොඩාක් questions, even essay questions are asked from this production of gases under this chapter. So first see hydrogen. You know, hydrogen is a very light weight gas. We say its density is very less than air because the molar mass is around 2. Relative molecular mass is 2 grams per mole. It's a very light gas. So when you release in the environment, they will move up because the density is less. And hydrogen is combustible. The chemical, as far as their chemical property is concerned, they are combustible. ඒ කියන්නේ ඉක්මනට දහනය වෙනවා. So you can use as a fuel hydrogen. And they are not slightly soluble in water. They are colorless and odorless. So the main physical properties, their density is less than air. The main chemical properties, they are combustible. And they are colorless, odorless, main physical properties. How do you prepare hydrogen gas in the lab? So as I said before, the metals like zinc and magnesium, those who are moderately reactive elements, are reacted with diluted acids, hydrochloric acid or sulfuric acids. So the hydrogen is displaced, the hydrogen gas can be produced. So zinc goes with chlorine, zinc chloride, and the hydrogen gas is produced. So this is the balance equation where when the zinc is produced, the zinc is reacted with hydrochloric acid. This is one of the ways of producing hydrogen gas. There is a setup how this gas is produced. So let me explain this setup. This is a very important setup where you should remember this. You should be able to label the equipments. So most of the essay questions are asked on this particular part. So in this case, what we take is a conical flask in your lab, and we add zinc granules here into the conical flask, and we use a thistle funnel here, where the acid is added through this thistle funnel. So when the acid is added, the zinc react with HCl and they produce hydrogen gas. So these produced hydrogen gases are collected through this tube, we say delivery tube, via a shelf called beehive shelf, and this is collected in a special jar called gas jar. So finally you will accumulate, the gas hydrogen is accumulated in the gas jar. So this is filled with water at the initially, and then the water level start to drop when the bubbles rises up, so the where the hydrogen gas is collected. So this is a special beaker-like structure called trough, right? And what are the equipment we use? The conical flask. This is coke where you insert the thistle funnel and delivery tube. Thistle funnel, delivery tube. So delivery tube is inserted through beehive shelf. This is the real picture of a beehive shelf, and it is collected in gas jar. So you see this gas jar is kept inverted or downwards, not upwards. මේක මේ අනිත් පැත්තට හරවලා තියෙන්නේ. So it is collected through water here, where the hydrogen gas is collected through water. Down displacement. We say down displacement. Make it displace වෙලා යනවා hydrogen gas එක. මෙන්න මේ ක්‍රමයට කියනවා the method of collection of hydrogen gas through this setup. අපි කියනවා downward displacement in water. The downward displacement of hydrogen gas. So you should be able to label this equipment and their particular functions. So we use zinc granules here. Sometimes we use zinc powders, where the powders will give hydrogen gas very fast, since the rate of reaction is greater when it is in the powder form, because its surface area is more than granules. You can add HCl or any sulfuric, or generally we use HCl and hydrochloric or sulfuric acid in diluted conditions. And the thistle funnel should be immersed in the solution here. It should be kept immersed. මේක ඇතුළට ගිල්වලා තියෙන්න ඕනේ. Delivery tube should be kept above the solution. මේකට උඩින් තියෙන්න ඕනේ. Can you think why? ඇයි මේක උඩින් තියෙන්න ඕනේ, මේක පල්ලෙහා තියෙන්න ඕනේ? If you keep this thistle funnel above the solution, hydrochloric acid, what will happen? The hydrogen gas will be escaped to the environment, making එළියට යනවා. So that is why we kept immersed in the solution. Delivery tube එක immerse කරලා තිබ්බොත් එම hydrogen gas එක අපිට collect කරගන්න විදියක් වෙන්නේ නැහැ. So you have to keep it above, because to collect the hydrogen gas which are produced inside this conical flask. මේකත් අහනවා විභාගවල වල, right? So not in this way, this is wrong, right? And this is the correct way of set up the instruments, apparatus. The next part is, so when you take this gas jar out from the system, you have the hydrogen gas which is accumulated in this gas jar. When you take it into the air, then make එළියට ගන්නවා. වාතයට ගත්තොත්, air ගන්න ගත්තොත්, hydrogen gas will not sink here. It does not sink because its density is less. It will remain in the gas jar because it will go up. මේක උඩට තමයි යන්න බලන්නේ. ඒ හින්දා we keep in the air with downward displacement when the hydrogen is collected. Nikanga, if you turn this upside down, upward displacement, the air, the hydrogen will go out of the system. You cannot accumulate since its density is less. When the hydrogen gas is in air with downward displacement, when you add, we say for example, you can use a splinter with a flame. So when you insert we say for example the splinter with the flame, it will burn with a pop sound. It will give a pop sound and make a hari වැදගත් identification of hydrogen gas. So how do you identify hydrogen gas? When you insert a splinter, right, the burning or with the flame splinter into the gas jar where the hydrogen gas is collected, it will give a pop sound. So that is how you identify the hydrogen gas. And the users of hydrogen gas are considered, and they are used as a fuel in rockets. මේක දැන් ගොඩක් ඔය rocket වල fuel එක විදියට use කරන්නේ hydrogen gas. And also it is used in production of margarine. So production of margarine, they use hydrogen gas. So this is very important MCQ question. So in order to produce margarine, they use hydrogen gas. In addition to these, hydrogen gases are used to produce ammonia and for the reduction of organic compounds. මේ අතරින් වැදගත්ම දේ තමයි hydrogen gas is used as rocket fuel and also in the production of margarine. So these are the important points. Let's move on to carbon dioxide. So the carbon dioxide gas is not like when you compare with the hydrogen, relatively their density is higher than air. So they will sink, they will not move up because their relative molecular mass is more. They are non-combustible as far as their chemical, one of the chemical properties is concerned. They are non-combustible. ඒ කියන්නේ දහනය වෙන්නේ නැහැ. They are against the combustibility. That means they are used as extinguisher. Fire extinguisher. ඒ කියන්නේ නිවන්න. ගිනි නිවන්න use කරනවා carbon dioxide. They are also slightly soluble in water. They are colorless and odorless. So how do you produce carbon dioxide gas in your lab, you can produce carbon dioxide gas when you react acids, dilute acids, with any carbonates or bicarbonates. For example, calcium carbonate, magnesium carbonate, monohari carbonate එක. Or bicarbonate, calcium bicarbonate, magnesium bicarbonate, any bicarbonate, any carbonates, when they are reacted with an acid, they will give carbon dioxide gas. So this reaction is another very important reaction. CaCO3 when reacted with HCl, they give it's a salt, calcium chloride plus water and carbon dioxide. So it's a very important, and to balance this, you can put in front of HCl 2 as the coefficient, the value. මෙන්න මේක කටපාඩමේ තියාගන්න මෙන්න මේ carbon dioxide production formula එක. නැත්නම් මේ chemical reaction එක. Okay, how do you produce carbon dioxide in the lab? Same setup as how we produce hydrogen gas. අර setup එකම තමයි. Conical flask, cork, thistle funnel, delivery tube, beehive shelf, trough, gas jar. The only difference is instead of zinc or magnesium, අපිට අරකේ zinc නැත්නම් magnesium දාන්න පුළුවන්. මේකේ දාන්නේ අපි carbonate එකක්, calcium carbonate or magnesium carbonate or any bicarbonates are used here. You add the acids, again immerse the thistle funnel into the solution and keep the delivery tube higher than the solution, above the solution where the carbon dioxide gas is produced. Again it is collected downward displacement in water, of water, through the beehive shell. Now the water was filled initially in the gas jar and gradually the gas is collected in the gas jar and the carbon dioxide is produced in this manner. But when you take this gas jar out to the air, so remember, don't keep it downward because the carbon dioxide is denser than air, they will try to sink. Make a එළියට යන්න බලන්න. So soon after you take the gas jar from this setup, turn it upside in the air. So in the air, the carbon dioxide should be in upward displacement. මේ උඩ පැත්තට තියෙන carbon dioxide. Hydrogen ගන්න බෑ මේ විදියට. Because hydrogen එක මෙතනින් මේ පාවෙලා යනවා, float වෙලා යනවා. Sink වෙන්නේ නැහැ. Carbon dioxide මේක ඇතුලේ sink වෙලා තියෙනවා. So how do you identify carbon dioxide gas in your lab base? So that you know the lime water will turns to milky. So when you add lime water to this carbon dioxide containing jar, so it will become milky. So because it forms calcium carbonate. But if you add more carbon dioxide into after it becomes milky, the milkiness will disappear. More than because it makes another compound called calcium bicarbonate. In a මුලදී කිරි පාට වෙනවා, milky වෙනවා. Because of calcium hydroxide is lime water is calcium hydroxide. When they react with carbon dioxide, it gives calcium carbonate. Carbonate is calcium carbonate is milky in color. So further reacting with carbon dioxide, will this calcium carbonate will converted to calcium bicarbonate, so which is colorless. එහෙනම් ඉස්සෙල්ලාම කිරි පාට වෙලා ඊට පස්සේ තවත් carbon dioxide දැම්මොත් ඒක colorless වෙලා යනවා. So this is how you identify carbon dioxide gas. Lime water turns to milky. Hydrogen gas gives a pop sound. So what are the users of carbon dioxide? So this carbon dioxide is used as dry ice. So you know when you go to the fish market, you get the ice cubes, so they will become liquid and the liquid වෙලා තමයි හැදෙන්නේ. දැන් මෙතනදී liquid වෙන්නේ නැහැ, gas එන්නේ. Dry ice එකේදී you don't get a liquid here. That is carbon dioxide. So these dry ice are used as a supercoolant to protect food and also it is used to make artificial rain. And මේකත් මතක තියාගන්න. In order to make artificial rain, they use dry ice, that is carbon dioxide. And also carbon dioxides are used as extinguishing fires. මේ බලන්න දැන් අපි දන්නවා ගිනි නිවන උපකරණවල. So those who used to extinguish fires, they use this bottle you have seen. It's mentioned carbon dioxide. මේක තකා යන්නේ ඒක එතනින් එන්නේ ඇවිල්ලා carbon dioxide gas එක තමයි. So it will remove the fire. And also carbon dioxide are used to make soda drinks or fizzy drinks. Right? And also carbon dioxide we know that is used in blast furnace as an ingredient because to make carbon monoxide. Next gas is oxygen. So oxygen is again high dense than air because its molecular mass is 32. It's combustible. Hydrogen combustible. Oxygen combustible. But carbon dioxide is non-combustible. Again, They are slightly soluble in water, colorless and odorless. How do you prepare oxygen gas in your laboratory? That is decomposition of potassium permanganate. මෙන්න මේක හරි වැදගත්. එතන දෙකක් එන්න ඕනේ. Potassium permanganate. So it will give potassium manganate K2MnO4 plus manganese dioxide MnO2 plus oxygen. මෙන්න මේක මතක තියාගන්න. අර reaction තුනම hydrogen gas producing reaction, carbon dioxide gas producing reaction, and then the oxygen gas producing reaction. So this is the main reaction where you can heat the potassium permanganate and it will be decomposed and produce oxygen gas. In addition to potassium permanganate, you can use several other components available in your lab where the potassium nitrate, hydrogen peroxide, potassium chloride decomposition are used to produce oxygen gas. Potassium permanganate වලට අමතරව you can use potassium nitrate, hydrogen peroxide and potassium chloride to produce oxygen, not only from potassium permanganate. Setup is little bit different than the production of hydrogen and carbon dioxide, not like sophisticated as how we produce oxygen and carbon dioxide here. No any thistle funnel, no any conical flask. Take the boiling tube, add potassium permanganate crystal which is purple in color. Now you use in the burner, Bunsen burner, you heat it. Upon heating, the potassium permanganate is decomposed, the oxygen gas is produced inside this boiling tube. So oxygen gas is collected in the water by downward displacement. So where in the gas jar you collect the oxygen gas. So when you take it into the air, since the oxygen gas is dense, so you should keep it upward displacement in the air. In order to identify the oxygen gas in the lab, you can use a glowing splinter. Glowing splinter කියන්නේ අපි splinter එකක් අරගෙන පුලිඟුවක් අරගෙන ඒක රත් කරලා off කරනවා. But මේක තියෙනවා. It will be glowing here. So when you insert the glowing splinter, it will relight. Yes, it will reignite if the oxygen is present. So how do you identify glowing oxygen gas in your lab? How do you write your answer? When a glowing splinter is inserted into a test tube or a tube where the oxygen gas is present, it will relight. Glowing splinter will relight or reignites. So this is how you identify oxygen gas. So the users of oxygen gases, they are used, oxygen is used in respiration and combustion, and also in underwater diving they use oxygen. Even in space travel, the oxygen cylinders are used, and in welding industry they use oxygen to burn, and also it is used in sulfuric acid and nitric acid productions. So these are the users of oxygen gas. Now there are a set of questions that are asked here. You can answer quickly. You will be able to write these answers and check the answers. The answers are given, so please answer them. You should be able to name these apparatus A, B, C, D, E, F, G, H, I. You know what is A is. A is an acid, HCl acid. B is the conical flask. C is the cork. Yeah, what is D? Thistle funnel. E is the delivery tube. F is trough. G is beehive shelf. H is, that is gas jar. I is, since it's zinc granules, you get the hydrogen gas. If it is calcium carbonate, you get carbon dioxide gas. So you can answer the questions. So whatever the theories I explained here, the answers are here. Please write your answers and check with them. And again, on calcium carbonate. So answers are given here. Please try to, you can check your answers whether they are correct or wrong. And on oxygen gas, set of questions are given here, and you can answer the questions and check your answers, right? Which I explained here. So remember, how do you identify oxygen gas? When a glowing splinter is inserted, it will relight. So this is the end of this chapter. I have briefly explained on structure of matters. I hope you enjoyed and wish you all the very best.